This section is entitled Networking, Know How to Use Ingress Rules. So when I first read up on Ingress, I was terribly confused because I had just learned about load balancers and the vocabulary around Ingress seemed to be exactly the same thing. And the answer is essentially it is exactly the same thing or very similar, but more flexible, right? And the big difference is that a load balancer only deals with a single service, right? You expose a single service. But an ingress actually allows you to have rules around how traffic gets routed across multiple services, okay? And one big difference also is that ingress rules only apply to HTTP or HTTPS. Okay, so that's another big exception. It's really only about routing essentially web traffic. So again, the main concept here are what we should think about ingress is some abstract rules that are handled by something called an ingress controller, which we'll talk about in a second, that then routes HTTP or HTTPS traffic to various services within the cluster. And again, it's all about exposing it externally. And then the ingress controllers are the actual logic or implementation. It's vendor specific that takes those rules and manages outside resources to make this all happen. So for example, in the case of Amazon AWS, as you apply ingress rules, the ingress controller that we'll use will actually drive an outside external application load balancer, an AWS application load balancer, that will drive traffic to our services. Okay, so that's, and the one advantage of this, I guess, is maybe from a cost perspective. Instead of if you had 10 services, if you were just using load balancers, you would have 10 external load balancers, one for each service. In the case of an ingress controller, you can actually have a single application load balancer front-ending all of your services. So that's obviously a cost savings there. Okay, so in order to make this work, you need something called an ingress controller, which is an add-on. You have to add your system that looks at these ingress objects and then applies them. That's the word controller to build your application load balancer and whatnot. Okay, so in this case, we're going to use. Let me just open up a couple. We're going to use the AWS ALB ingress controller. And the docs for this are here, and one of the things we'll learn here, by the way, is the documentation, if you can find it. It's probably under a guide. A lot of this is all about these annotations, and there's quite a few of them, right? So what you do is you build these ingress objects, you apply annotations to them, and that controls how the ingress controller is going to operate on it. And we'll just touch upon a couple of these for AWS, not all of them. In terms of installing it, there's instructions on Amazon provides called ALB Ingress Controller on Amazon EKS, and it has a fairly lengthy and detailed instructions on how to install the controller into your environment. I'm not going to go through the examples on screen. It's a little bit nitpicky. And you got to be somewhat careful about following all the rules. So again, I'm not going to go through that on screen. So let's see. Oh, all the steps worked, by the way, except for I ran into one bug, and I'm trying to remember what the bug was here. Oh, right. So when I tried to do one of the steps where it mentions running some document from an HTTPS endpoint, I ended up getting an error, right? And the fix here was basically to download the file first, right? And then change it to the policy document file, then with the policy JSON. I don't know why, but this did definitely work for me also. So if you run into the same problem I did, you can just download the policy document and apply it locally or from the local file. Okay, enough on that. Okay, so at this point, imagine you already have done all the steps, and now you've got your ingress controller running. You don't have it, nothing's fundamentally changed other than that your system is ready to support ingress objects. Okay, another thing, if you read the docs, they'll talk about something called ingress class. Now, basically what an ingress class is, so we have our controller running, right? And you want to build this ingress object, which is something that's like the rules about how you want, traffic to be, exposed for your services, right? The deal here, though, is you need to your rules need to be bound back to that particular controller. And the new way of doing it is you create this intermediate object called an ingress class, which references the controller and any other configurations that are specific that you want to modify for that controller, right? And then you have ingress class is basically front-ending the controller, and then as you write your ingress objects, you can point them at the class, and now that makes it so that those rules are handled by that particular controller. Okay, so it's an intermediate object. Now, the older approach is much simpler, and it's actually the way that the AWS controller works, is you just tag, I think I have an example here, you basically add to your ingress objects an annotation of a particular format, kubernetes.io/ingress class. In this case, the value is ALB, and that is actually how, right now with AWS's implementation, how the ingress gets tied back to the ingress controllers just by this annotation. Much simpler. Okay, so that's how we're going to do it. Okay, so what is this ingress? It's almost easy to see by example, but in fact, I think I will do it. Let's look at the most simple example we can find. Let me bring it up, and then I'll walk you through the main elements of it. Okay, this looks like super tiny. We'll go like this. There we go. Okay, so the first example we're going to look at is called just ingress. And let's start with outside of the ingress, let's talk about the other pieces of the puzzle. So this is about exposing services. So the first thing you need to do is you need to create some sort of deployment. I think in this case I've got just, I've just got a Apache web server running on port 80, right? And I've I was just keeping things simple. I just have one replica now instead of 3. Just getting busy otherwise. Okay, so that's it. I got a deployment, right? And then I have a service, right, that it's exposing that exposing that deployment. And one important thing here too is for this particular AWS ingress controller implementation, you actually have to specify the type of service as a node port. And I didn't catch that at first, and I couldn't get this to work. So you have to make the service a node port. And if you remember that, what that does is it exposes your service as a port on each of your nodes. So that's something to keep in mind, right? Okay, so nothing terribly new at this point. Now the ingress is where it's new, right? Now let's pay attention here, see what we got here. We have our usual labels. Okay, nothing special there. The name is not special. Okay, so there's really just annotations and specs. So let's look at the annotations first. Annotations, as I mentioned earlier, this first one is what allows this ingress rule to be tied back to the controller, right? So we already saw that. And then I mentioned that there was all those annotations. And in this case, I want an internet-facing, in this case, it's going to build, just so you know, this is going to build an application load balancer outside, and I want this internet-facing. So I specified this tag. This might be the default, but the docs actually had this in there, so I left it in, right? So this will create basically an application load balancer externally that's internet-facing, right? And then to configure that load balancer, again, the goal is to map, basically that load balancer into our services. You set up rules, okay? Now, the rules, the simplest rule is where you specify just paths, right? So you see the rule reads, look for HTTP traffic, then here's all the paths. And this particular path is matching a wildcard for all paths. So this is kind of a dumb one, where I'm just saying, hey, take any traffic that you see that's HTTP and send it to the service named example release name on port 80. Okay, so that's the structure here is paths. The paths are a list of objects which consists of path endpoints and their back end that's supporting it, right? And I think the easiest way right now is just to go ahead and see how this one runs, and then we'll add more complexity as we go. So let's switch this, and I'm going to do helm install dev ingress. Now this takes a few minutes to settle down, so I'm going to pause the video, and then I'm going to come back and inspect it when it settles down. Okay, we're back. So let's see what got built here. Again, I waited a few minutes here. Okay, so what you're looking at here is, okay, so let me clear the screen here. Okay, so first, what do we have here? We have our deployment, right? And then that deployment created a replica set, which created a single single pod, right? And then we have our node port, right? Then we also have kube control get ingress. Okay, so now we also have this thing, right? That is our ingress, right? And you notice it has an address associated with it, right? And this is basically the address of the load balancer itself. Okay, so then what we can do is we can look at the load balancer. In fact, that's the same DNS name right there, that 2C should be the same as this one right here, right? Okay, so what this really did is outside it created a load balancer, right, that is taking all our traffic in, and then it has listeners, so it's listening on port 80, and let's look at the rules here that it created, because this is what's called an application load balancer, which is allows you to have rules around where traffic goes. And it says, okay, if the path is /*, route this traffic to this thing, which is what's called a target. We'll look at that in a second. And then otherwise, just returns a 404. Okay, so this rule basically got built because we created that ingress, right? So let's look at that target now. Targets are these target groups, and there's one target, which is, right, and that target is pointing, well, let's see, what is this pointing? This is pointing at each of our node instances on a certain node port, and that node port happens to be the same node port that is, I think it's probably listed in the service itself. So if you look at the sample dev service, that 31190, that is the same thing as that 31190. And you notice it's healthy. So what takes a few minutes, just so you know, is for this target to come up as healthy, and until that happens, you can't actually test it. And this is really what takes a few times. You just go to this target screen and wait for this to become healthy. Once your targets are healthy, you can then go back to your load balancer description. You can either grab the URL from here or from the kubectls out command line. And if everything's working, I'm now routing through the load balancer into that one service. Now this was kind of basically replicating essentially what we did with a load balancer, just using a ingress instead, right? So not terribly exciting, but that's the first basics of it. So let's get rid of this one. Helm uninstall dev. Okay, I'll let that uninstall for a few minutes, and let's look at the next example. Next example, what we're going to do is look where we're going to take multiple hosts, right, and then route them to different services, okay? And then just so you know, the next one we'll do is we're going to use a single host, but with multiple paths and do the same thing. And the last example we're going to do is HTTPS. So let's look at ingress multiple hosts. So let's look at that and see what it looks like. So here we have, what do we have? Okay, so to illustrate this, I have two different applications, right, or two different services. One, just to distinguish them, I'm running one Nginx web server and one HTTPD server, right? Otherwise, they're just like before, they're just node ports. And then deployments are pretty much, what you expect. They're just the Nginx is running Nginx, and the other one's running Apache HTTPD. Okay, so that's not terribly new. The interesting part is in the ingress itself, and as before, we have our same exact annotations. Nothing's changed there, but now we have more complex rules. So we didn't touch upon it last time, but rules can also have hosts, right, that are the first part of the match. So the idea here is this rule. There's two different rules here, and you notice that one has a domain name of HTTPD todos.rs.com, and then one has Nginx, right? And the idea is this rule, top rule, only will match when the source. This is all HTTPD, so the domain name that HTTP request is coming on has to be this, otherwise this rule doesn't apply, and vice versa for the Nginx example. So if it matches HTTPD, then any path, right, that it sees gets mapped to the service named HTTPD service name, right, and likewise Nginx. So pretty much it. So this is basically doing host-based routing, right, and we're routing it not based on path, but on the host. So let's run this real quick and see what this looks like. Okay, so I do helm install dev ingress multiple hosts. Right. Now again, this is going to take a minute or two. So what will happen is I'll observe it in its sort of unready state. So first thing you'll do is you do kube control get all. You'll see all of your normal pod stuff, right? Everything's running. Actually, everything looks smooth here. If I get the ingress, I probably even see the load balancers, looks like it's already been assigned, right? But if I was to go into my load balancers, so let me go back to load balancers. I have a new load balancer. Let me refresh my screen. Should have another load balancer just got created. So it's still, you see right here, status is provisioning. So this is not ready yet, right? So the first step is the load balancer has to be active, and then you want to look at the targets. So if I bet you, let's see if there's even targets here. Let's see. If I go under target groups, see, I see 2 targets, and what status are they in? Yeah, they're still initializing, right? So you're really just going to have to, I'm going to pause the video and wait like 2-3 minutes until first clue is the load balancer better be not provisioning but active. Let's see if it's ready yet. I don't think so. Okay, I'm going to pause the video. Here, give me a second. I think I accidentally started recording a minute ago. Give me a second. Okay, I'm back this time. I think I maybe had a long pause there because I accidentally started recording. So we'll see how the video goes. Okay, so I'm back now. And you notice that the state is active here, which basically means the load balancer is ready. Let's look at the listeners, right? So there's a single listener on port 80, but let's look at the rules this time. So now it says, if the host is HTTPD to DRSCOM and the path is this, route to this target, and vice versa for Nginx, otherwise 404. So by doing the 2 different hosts, we now created an application load balancer with 2 different rules, right? And then, of course, you can now see the target groups here. First one, it's got a target that's healthy, and you notice it's hitting 1 node port,
and that's the node port for one of the two services, and vice, there's other ones. So this is kind of what's how under the hood. This is what's working, and to validate this working, I actually have to go into DNS and route traffic, with different DNS names. So let's do that real quick, just to complete this, even though it's a little tedious here. So I'm going to go to my hosted zone, and let's see. Let me get rid of the garbage one I have here. That's an old one I have. Okay, so I've got a clean zone here. I'm going to create a record set. I think I said one was called HTTPD, right? I need to map this to the application load balancer. And then the other one was Nginx. Again, these names actually matter here because we are routing based on these names. Okay, so I have two different names, and let's see. So Nginx, so I have to do NS lookup. Let's make sure. Sometimes it takes a few minutes for DNS to kind of get propagated. nginx.todos.us.com. There's a name, so if I curl it, and this is definitely the Nginx page, right? So if I go to here, this should now Nginx. There's Nginx, right? Now the other one was curl hbd.todosrus.com, and that's the other one here. And if I was to go to here, hbd, there, and that's actually the default page for the Apache web server. Okay, so long story short, we just illustrated host-based routing. And then, so let me get rid of this one. So let me go helm uninstall dev. Okay, let's go back to tutorial. So, well, let's look at this one. We're going to look at the next one, which was multiple paths, right? And so here, let's see how I did this one. If I go to code here, multiple paths. If I look at the template here, okay, so I have now an A and a B, right? Services, right? And then I have another ingress, right? So let's look at how I did this one. I needed to. This one's a little bit tricky because let's see. Let's start with the deployment itself. Deployment here, I'm using HTTP, right? But the tricky thing here, and we haven't talked about volumes yet, but they basically allow you, in this case, what I needed to do is I needed to create a file, because it's based on paths. Each of them had to have, like one was, I'm serving up something under /A, an index file, right? And the other one, B, if I look at B deployment, I'm serving up another file that says B, right? That is on a path of /B, okay? Now, so basically, this is basically, and then I have this config map, which is basically the index file. So the index file itself just has index.html. It's just a header with A, and the other one says header B. And all that setup is so that I have two different services, right, that both serve up content on different paths, one on /A, one on /B. So then I can refer to them in my ingress. And so see the ingress here now, instead of having different host names, each rules have basically a blank host name, which basically means any host name. And this says anything that matches path A/, send it to this service. Anything matches B/, match it to this service. Now, because this is virtually identical to the previous example, I'm not going to deploy it and run it. You can deploy it just like helm, install, dev, this thing, and then you will have basically the solution. So nothing terribly excited, but just illustrating that you can route on paths also, right? And obviously you can route on hosts and paths. union of those, right? The last example, and I probably, well, I'll talk about it, and then I'll decide if I actually want to run it. So far we've been using HTTP, not HTTPS. So, you can also deploy this as HTTPS instead. And the good news, this one's actually super simple. This is a single service. What's this one? This is just running a single service of Apache, right? Nothing special. The service is a node port, right? Okay, nothing special there. In Ingress, the bottom part looks identical to what we did the first time, right? I just have a path, right? And then I refer to the service name, right? The only difference is I added an annotation, right? So here you notice now I've added an annotation called certificate ARN, and I refer to in this case, this is a AWS certificate manager certificate, and it's a wildcard certificate, right? So that I created, right? So that's in, if I go to here, that's under here. If you look at certification manager, I have created a certificate, star.tudoros.com, and the ARN is this, this value right here. So that's what gives me the SSL or TLS certificate. So I'm not going to deploy this one either, because it's the main interesting part is just that there's annotations, and there's all sorts of annotations that it's almost actually overwhelming. That for this particular controller, you can control all sorts of stuff on that. Basically, you're driving configurations into the application load balancer, which is a pretty complex thing in the world of AWS.